space environment. Dan's going to speak for a little while, and then after that, we're going to have an interactive panel discussion, and at some point, I'll also invite you to join us with some questions, and I would really welcome that at that time. So this talk, again, will be filmed, and it can be viewed later online, and I now would like to welcome Dan up to the stage. Please come up.
Thank you. Thank you. Good morning, ladies and gentlemen. Thanks for coming. I've always been fascinated with the notion of space and looking at the stars. Looking at them up in the sky. It's not just decoration, in a way it's information moving towards us with the speed of light. That's why I make projects like these, inspired by the starry nights of the famous Van Gogh painting, a bicycle path which charges at daytime and glows at night. These are public space projects you can go to, which combine a practical agenda and a poetic agenda at the same time. If we can have some music.
It's just like rain on a starry night.
So that was about the stars. But today we talk about space and the space waste which is out there right now. What can we learn from planet Earth if we want to make new things happen in space? What are the problems and what are the potentials? And I'll talk about the future, the coming 50 to 60 years. But before we dive into that, I want to start with the history. I want to start with Kennedy. I want to start in 1962.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Not because it's easy, but because it's hard. And they were on a mission to go to the moon. And this was euphoria. We had the Jetsons as cartoons. We built Concorde. There was a real notion of moving forward. Weirdly enough, this is 60 years later. This is not an undiscovered Jackson Pollock. This is the current space waste, which is floating around our universe. So this is our precious Earth. And this is all the junk around it, more than 8.1 million kilo of it. It started in 1957, launch of Sputnik, Apollo, pieces of satellites and missiles started to collide, creating this layer of junk around our Earth. So somehow we're not satisfied ruining our planet Earth. We sort of keep on persuading that mission outside our Earth. This is shocking for somebody like me. It's almost obscene. And even Kessler, the famous space expert, calculated that if we continue like this, which we will, there will be so much junk around our Earth, it's called the Kessler Effect, that basically we're sort of trapped. Everything we launch creates more collisions, more particles, more collisions, etc., etc., etc. So we have so much stuff around it that we cannot launch more new missiles. That will happen in the coming 25 to 30 years. So we will be here in Davos and Dalian in 25 years and saying, okay, good news, we found life outside planet Earth. Bad news, we can't get there. Okay, that is not the mission and the session I think we should have. So we launched Space Waste Lab, collaboration with ESA, the European Space Agency. Because it's a big problem. These particles, although they're very tiny, and you think they're very, very far away, like 2,000, 20,000 kilometers, why should we care? Well, because a very tiny particle, if it hits an existing satellite, it's like a bomb, 27,000 kilometers per hour. So it's a threat to our day-to-day communication, our satellites, our GPS, our 5G. If we continue like this, no more Facebook, no more worldeconomicforum.org, no more Facebook. So although, that's what I like about it. On one hand, it's very abstract, and on the other hand, it's very personal. It's our communication, it's our intimacy. And it's one of the most environmental concerns of our time. Okay, so how do we fix a big problem? Okay, very simple. Phase 1, creating awareness, making sure that people know about it. Phase 2, fixing the problem with technology. But also phase 3, upcycle it, add a new value to it, give a new meaning to it, so we don't make the same mistake again and again. So we started to collect information of 29,000 particles larger than 10 centimeters. And we know exactly where they are, how they are named, and the exact position above our head. And in order to sort of create a larger awareness for people, we started to visualize this with these huge lines of light above your head, showing real-time the space waste where it is above you. So thousands of particles like these are floating around our planet Earth. Each one has its own name, its history. It's a big problem, but maybe it's also a big potential. What can we do with it? 8,000 people at the opening of the Space Waste Lab, creating awareness, scanning, thinking, revealing. And inside we did an exhibition about the history and the future of space waste. A lot of people came and were actually interested. And I have it here, this is really cool. We got a real piece of space waste from one of the astronauts from the Hubble telescope in 1990 who was doing maintenance. It sort of drifted away and he captured this. This is priceless. Yeah? And this is very interesting. So we looked at this and realized that there's 8.1 million kilo of space junk. But maybe we can also see it as an ingredient. What would you build with 8.1 million kilo of Lego blocks? Eh? That was sort of the question we asked. Here, you can maybe show it around. Don't drop it, please. So we got 2,000 students, high school kids, and experts from ESA and NASA working together and asking, what can we do with it? How can we upcycle it? Many ideas came in. This is in Dutch, collect the space waste and put it into a black hole. Maybe not. Or here, we need to build a wall from space waste and make the aliens pay for it, make space clean again. Okay. It's not me, no comment. Okay. But the real solution, most likely, everybody agrees, lays here. Cube satellites, mini satellites, quite affordable. You can attach a net to it. So there's a piece of space waste, and patch! There it goes. Hoppa, we have it. Not fully proven yet, but the most feasible as we speak. So we have a satellite, a net, and that is a way to capture it. Then we had a problem. Nobody cared. Nobody likes to clean up. It's like when you are a boy or girl, and your mother comes and says, clean up your room. You're like, yeah, whatever, Mom. I want to have popcorn. I want to watch television. Cleaning up is not fun. And this is, ladies and gentlemen, where the role of design came in. I'm not smarter than ESA or Airbus or NASA. I'm not, because they're really, really smart. But what I can do is create a new link, design a new value. So we started to look at that. And for example, question, if we capture it with the net, can we use it to 3D print houses on the moon? Yes, this is already on the agenda of NASA to do this. Why are we shipping very expensive material from the Earth all the way up? Just capture what is there and 3D print it, creating a new type of architecture, a new type of geometry. Or here, maybe a bit.
そこでもっと先を考えると、これを使ってリフレクター反射板を作る、それで太陽光を反射しまして気候変動に関して必要なところに配置して防いでいく。それからこういうゴミトラックを作るか、ゴミ用のローバーを使ってこのように宇宙を回って集めまして、そして人工衛星の方に使っていく。もっと
is this one. Once we have the net in a safe and controlled way, and it hits the Earth's atmosphere, what happens then? It burns. Yes, very good. So waste is light. That's interesting. Can we create artificial shooting stars as a replacement for fireworks? And apparently, yes, we can. So this is what we're working on now, right now, to go to countries. For example, the Netherlands is spending 70 million euro on traditional fireworks. It's very polluting. People lose their eyes. Whole villages are burned to the ground. We find it very normal. China, a lot of cities in China are already abandoning fireworks because of air pollution. Dubai is spending 8.1 million euros, I think, per year. So basically what we're saying is like, okay, you're already spending the money on fireworks. Let's spend it on this. You create a new sustainable way of fireworks, and at the same time, you clean up space. That is sort of the mission we're on with the Space Waste Lab. And that is the way I think we should think to take something which is a problem and turn it to a potential. It's not necessarily easy, and it requires some linking thinking between creativity and engineering, but I think this is the only way to move forward. We're not going to make it with the existing way of thinking. So ladies and gentlemen, to conclude, that's how I would love to see space. A space to explore, a space to learn, a space to make mistakes, but also a space where we learn from the mistakes from planet Earth, try to be the best, to try to improve, and trying to find a new harmony between economical progress and humanity. Thank you so much. Yes. Thank you.
I hope you'll bear with us for just a couple of minutes. Behind me, they're going to put a couple of chairs for the panel discussion we're about to have. But while we're waiting for them to do that, didn't you kind of love this idea of...
You're 14 minutes.
I just took a few words down because Dan, being an artist, also, to me, struck me as art with his words, too. This idea of a practical and poetic agenda. Wouldn't that be nice if we could do more with technology that was both practical and poetic? I love the notion of the undiscovered Jackson Pollock, but not really. That's not what it was. It was waste around the planet. And could we actually take this waste and do something else with it that could be useful or even lovely, like those fireworks? I'm thinking about fireworks because where I come from, we'll be having fireworks a little later this week. Okay, I think we're just about there. Can I ask the panelists to please join me up at the stage, and I'll introduce you when we get there, and Dan, you as well, please.
Please.
And I love this backdrop too, by the way, thank you. So now we've had some beautiful visual flights of fancy, and we're going to talk a little bit about some of the technological realities there, perhaps some of the business potentials there, perhaps some other perspectives on what we might do or might not be able to do. And I thought, because everybody hasn't met you yet, Dan, I hope you don't mind.
Please.
If I ask, maybe I'll go from all the way out in, if you don't mind. Dirk Carsten Hoek is the Chief Executive Officer, Airbus Defense and Space in Germany, and also one of our young global leaders. And then I'd like to introduce Sarah bint Youssef Al Amiri, Minister of State for Advanced Sciences of the United Arab Emirates, and also a young global leader. Could I ask you both just, a little, some initial impression. First, please tell us a bit about your work and what you normally do around space and research and technologies related to that. And maybe after you share that, if you wouldn't mind sharing some initial impressions.
Ladies first.
Good morning, everybody. So just first, I don't know if you can hear me or not.
It seems a little quiet.
No.
It seems quiet,
Yeah. Okay. I hope this is better.
Yes, yes,
All right,
better sound,
perfect.
thank you.
So just to start off, I've started in the space sector in the UAE very early on with the development of the capabilities for developing satellites in the UAE about almost 11 years ago. I'm the science lead on the Emirates Mars mission. That's sort of the other hat that I wear next to the federal level development of science and technology for the UAE. We're using the space sector as a catalyst for the development of talent and for reshaping the way we utilize talent in the sciences and in engineering to start doing design and development. And it's one of the cornerstones of moving towards a more diversified post-oil economy. Just as an initial impression, and what I really liked about what you just showcased from an artist's perspective is it looked at space and space debris from an angle that was, what do we do with the waste? And it wasn't imposing. So a lot of things that I think we hear in this sector is imposing regulations when it comes to adding propulsion systems onto satellites and so on. And those inhibit creativity because the more guidelines you put to development and design, the more inhibiting it is to designers and developers for spacecrafts. And I really like the angles that you put, and you expanded the utilization of space debris, expanded how we approach utilizing space. And this is a topic that we need to discuss from different angles. And this is, and if this proves anything, I think multiple perspectives from people from different sectors and people from different areas need to be imposed and included within this discussion.
Yeah.
Yeah, we work in a company that is around 40,000 people working with space products. We produce everything from telecommunication satellites, Earth navigation satellites, Earth observation satellites. And we also look, of course, at space debris. And the NET is one of our daughter companies, SSTL. We were the first one to successfully be able to collect space debris. We look at other topics also, how we can support these kind of initiatives. We have an R&D project called SpaceTug. The idea was to create a satellite with a robot arm that can be multi-purpose. One of the ideas was behind it to do 3D printing in space, then construct any kind of structure, and also to take it with the SpaceTug from the LEO into the GEO. Also to look at refueling satellites, because the lifetime of a satellite is mostly defined by the fuel capacity. So extend the lifetime of satellites, or even in the future putting additional modules in order to enhance the capabilities of a satellite. And yeah, the other topic would be to collect space debris with the robot arm and bring it down, deorbit it or burn it. Many things that you had in your videos we're looking at. But
Great.
the question is, who pays for it? And
Exactly. Yeah.
so every school and university now launching micro nano satellites that they have no obligation to deorbit, they have no obligation to burn it. So this will not, as you said, it's not sustainable. No one can continue like that. And we discussed in another circle of big space companies what could be incentive, because at the end it's all about incentives. How can you incentivize companies to do further development on that? And this could be like whoever launches something has to pay a certain amount into a pool, which will be then used in order to pay companies to collect debris. And could be based on kilos, could be based on how urgent it is. So there are a lot of incentives that could be placed in order to make sure that companies like ours invest billions of euros into the development of these kind of things. Another thing we do is on education. We have created a STEM center in Munich, where we found out that in order to collect enough talents for the future, especially also on the female side, and if you look at kids between 6 and 12, they're not conditioned yet, and they're not biased. So if you teach kids on coding, it's equally cool for girls and boys. And so we do this 2 times a week. I train them on coding and about space. And it was quite cool. I was running into one of the classes and talking to a 9-year-old girl, and she was like, so what are you doing about space debris?
Really?
A 9-year-old girl.
That's good.
And can you not invent something and collect the space debris? 9-year-old girl.
Yeah. Great.
So I think it's about already also
Yeah.
changing the mindset.
It's a different mindset.
Yes.
Yeah. Beautiful.
I love that actually, and I love the power of art to inspire us to think, and I love that idea of everybody pays a share to solve a problem that we all collectively have created. I'd like to come back to the debris just for a minute or two more, just for understanding for folks in the room. You just used the terms LEO and GEO orbits.
Yeah.
I think it would be good to tell people here what those mean, because it relates down to what you were showing, which is pathways
Yeah.
that waste travels. So the
They're
waste
highways.
travels in certain paths. Maybe you all saw that, and maybe you could
Yeah.
all, each of you, if you like, speak to that.
Yeah, you think space is really big, so it's everywhere, but they're sort of highways. They're sort of heights which have the perfect angle for satellites, et cetera, et cetera. And you're right, when I do a project like these, I learn a new word every week. So that's the LEO, that's the altitude that the satellites, and therefore the junk is always also...
Low Earth orbit.
Yeah.
When we look at LEO, we talk mostly about LEO constellations for telecommunication.
Yeah.
This is somewhere between 400 and 1,200 kilometers. I don't know if you saw, we launched our first 6 satellite in our OneWeb joint venture in February. And they are at 1,200 kilometers. They will be, in the next 2 years, we will launch 648 satellites in a LEO constellation in order to provide telecommunication service. Also, if you want to be in an aircraft, you're crossing the Atlantic, instead of having just that you can just download your emails, having high-speed internet access, these kind of things.
But it's getting busy.
It's getting
busy there, in
how
these.
deep
Yes.
and how high are these debris highways?
It's
How far off the ground?
220,000 kilometers, something like
Yes,
that. Yeah,
up to-
more or less. Yeah.
Yeah.
And satellites are getting downscaled. Before, telecom satellites used to be at GEO, so that's geostationary orbit. Large satellites that operated for 10 to 15 years and relatively stay there for decades.
Yeah,
at least 15 years.
Yeah, they stay there for decades even after decommissioning it. It's very hard for them to come down. And we see a large trend towards getting smaller satellites that get more things done, and their lifetime is shorter. And the purpose from that is so that you can have the technologies continuously updated, because the larger ones are very expensive and very hard to maintain. Not a lot of companies invest in maintenance of those assets. And with that trend, you see the low Earth orbit becoming more and more and more congested. And you need to understand that it's not only the space debris of the satellites that go up there, it's the vehicles that take them up there that also remain in orbit that you don't have contact with and are not able to utilize to bring it down. So we are going to continue seeing more congestion in low Earth orbit, and I think your rendering showed that.
Yeah.
It's very congested
that's a simulation.
in the area that we really need to use for most of the assets that need to go to space, so that our daily lives could be in the same way that we're currently living in. There's nobody here that lives without some form of attachment to an asset in space, be it from the data, be it from the communication, be it from any angle. Any point of your day, you're attached to something in space, and they're vital to the way we do things today.
Yeah.
We can't survive without them.
And exactly, and the question I would love to ask and maybe to answer today is, like, how can we not repeat the sort of mistakes or lessons that we've learned on planet Earth? And I think that's the beauty of art and design, or creativity, what you mentioned as well, and you as well, is that if we can't imagine how we want the future to look like, we won't get there. So it starts with sort of saying, how do we want it to look like and to behave? And then we figure a way how to make it happen.
And it becomes a vicious cycle, as you said, because in the past, as you said, it needed 4 years and several hundred million euro to create a geostationary satellite. Now we can, for OneWeb, we can produce 2 a day.
Really?
So it is changing, and if we don't do anything about it, we will definitely run into problems because, as I said, the life cycle of a satellite depends on the fuel.
Yeah.
If you need to do maneuvers to avoid collision, you reduce the lifetime of a satellite.
Yeah.
And this happens more and more.
So how would you fix space waste?
Yeah, I said.
How would you, like, if you look at this and the conversations you had already and we're having now, what do you think is sort of a roadmap for a sustainable space?
As I said, we should start with whoever launches something should pay a tax in order either be obliged to deorbit or pay a tax to a pool so that someone else will do the deorbiting and the ensuring that the space debris is collected.
So
this would be already a big change.
And shooting stars.
I would caution, though, from having an obligation to deorbit, because the beauty of where we've gotten to today and the access that we're opening up to emerging nations when it comes to having space assets has never been a point across the last few decades that space has existed. Now more than ever, more countries could own those assets and get the valuable data that they require to run things as business as usual. And at a time when we want to ensure parity across the board, regardless of income of the countries, we need to be able to ensure that access to space is still there. And deorbiting costs a lot. It increases the size, so it takes us the other way that we've gone down. We'll increase the size of the spacecraft. And something important that you spoke about was fueling. But something else that we need to invest in is battery technologies, because that's usually the first thing that would die out in a spacecraft. Investing in smaller, more effective battery technologies that could be operated for a longer amount of time in space, and that would allow us to use those small satellites that have a shorter lifespan and utilize it for a longer period of time.
And just so people are understanding what we're talking about, how big are typical satellites? So there were bigger ones and there are now smaller ones. What sizes are we talking about?
The geosatellites could be several tons, and they are like
so
room size.
Crashing that on the planet,
size.
not
But the
easy,
cube satellites
right?
are like
The
this.
cube satellites are...
The OneWeb satellite is 160 kilo fridge size. And then you have microsatellites,
that are
nanosatellites, any
tiny,
size you want.
CubeSats and so on.
I ordered one.
You ordered one?
Yeah, you can order it online.
So CubeSats, the smallest satellite is a 10 centimeter by 10 centimeter across CubeSat.
Yeah.
So
You can
and then it
beep.
goes-
You can send a beep, and it sends a beep back.
And while we're
You
on
can
this,
beep it. Yeah.
Ooh, sorry.
Yeah.
Sorry. While we're on this, I got excited.
Good.
How, when you're deorbiting something that's very large, you know, what I remember Skylab, that's how old I am. But how do you even begin to, I know it's expensive, but how does one go about doing that?
That's part of what we are obliged to do.
Use the propulsion and point it down?
Yes,
Yeah.
of course.
And if you didn't do that, how long would they naturally take to deorbit? Could be decades.
Really, really long. I don't know the exact time, but it's
40, 50.
but we will everything we launch we also either take down or burn, so that there are no remains in the orbits. But you talked about 29,000 objects bigger than 10 centimeters. We talk about a million of objects
Tiny.
below 10 centimeters.
Yeah,
which
but we
are
can't
not
track
monitored.
them.
They're too small to track.
Yeah, but they're still lethal. So yeah.
So one more question about the sort of technology landscape and framework, and then I want to ask some others about how do we grapple with this down on Earth. But you mentioned the Kessler Effect, and I'd like to hear from you all what is this effect when there's a certain amount up there, and then what happens? So if you were trying to send a new satellite up there on a vehicle, what would happen to it?
But Dan explained it already.
Yeah.
So
So Kessler is a space scientist who was actually one of the first with his team, of course, to calculate that if we continue like this in the coming 25 to 30 years, there's so much junk which creates so much collisions when we launch more collisions, etc. So then we are at the point of no return. So there's so much junk that everything we launch will become part of the trash again, etc., etc. And that was sort of a shock, I think, in the space world. They were like, like we're sort of trapped. Eh? We have this sort of layer of junk around our Earth. And I spoke with him via Skype. He's still alive. He just moved to a new house. And so I asked him, like, how do you feel to discover like this world disaster? Eh? because basically that's what it is. And he was very sort of, he's a
He's a mathematician.
Yeah, he's sort of calm, and he's like, yeah,
I did the calculation.
that's the reality, and everybody sort of agrees. But I think from a personal perspective, I think it's crazy that we accept that as a reality. So the need of urgency to fix it, but also to look at it, to realize that if we continue like this, we won't fix it. So we have to generate a different perspective and a different attitude of collaboration. So in a way, it's not a technological constraint or a money constraint, but a creativity constraint that we have to fix, a perspective change. Yeah. That makes it fascinating for me. Yeah.
So I'd like to talk a little bit about how we've recognized the situation and what we are doing, and in terms of regulatory frameworks, in terms of government discussions. Can you all update us on that a bit? What are you seeing now?
So we see discussions happening on space sustainability. I think in the Global Future Councils here in WEF is one of the places that this is being discussed. And different recommendations are there. I'll reiterate what to caution when it comes to those regulations, and it's let's look at them from the perspective of how can we make access to space better by removing some of the space junk that exists there, but let's not make access to space difficult because we want to make it better. And this is a very important point when regulations come into perspective and when development comes into perspective. And we are at a very important time when it comes to the development of satellites. And like you said, it's about, previously satellites took years upon years of design and development. Now they're becoming more reproducible because it's becoming more affordable. And because of that, we need to understand that we can't impose over stringent guidelines that inhibit this development. And something we need to look at is reuse. How could we reuse a lot of the parts that get you to space?
Yeah.
But how can we reuse the things that are currently in space? That's one.
Yeah.
The second one is the value proposition of space debris. What do we do with the space debris that's out there? How's it cost effective? And I like the idea of paying a small sort of fee to deorbit rather than, and I'd like to again stress on the amount of small, because you don't want to inhibit people going into this. You don't want to inhibit the private sector getting a value out of it. When we are talking about a space economy, we're talking about a space economy that has a private sector that is not entirely dependent on government spending, because we can't sustain space for further decades with further government spending. We need to allow for private companies to come out. One, because it enables access to the data that comes from those space assets that helps in various developments. It helps in urban planning, it helps in farming, it helps in natural disasters, it helps in communication where infrastructure for communication does not exist. It gives us the basics of life as we know it today. And we need to caution from having regulations that inhibit that just because we want to solve the problem of space debris.
Yeah.
And any regulatory framework needs to have those various perspectives in play and in place in order for us to continue in this development curve. It is a very exciting time to be in space. It is a very valuable time to be in space. And it is very important for us to continue thinking about how do we make space access continuous for the next generations to come, and how could we enable technologies for space access, again, for generations to come.
Nothing to add. I think that was definitely going in the direction we also look at, because we believe we need access to space, and I think having independent access to space will be crucial for all nations in the future. I think looking at science, I think what we know about Earth, a lot of that we know because we are in space and we can see from space towards the Earth. We monitor wind speeds, we monitor CO2 emissions, we monitor air quality. We can measure sea levels. So a lot of we work on agriculture, monitoring different areas in order to optimize fertilizing, irrigation, and so on. So a lot of what we know about the Earth, we know because we're in space. And So we have to continue that, and I think, as you said, it cannot be done only institutional and government. It has to be also from private sector supported, and but it also has to be clear. We cannot continue congesting the space as we do, and we have to have some rules. Even of course, we don't want to prohibit people from exploring space, but everyone should be clear that we cannot do the same as we did on Earth, as you said, in space.
Yeah.
So I want to give the audience a chance to ask questions in a minute, but I'm going to ask you one more so they can think of it. I was reflecting on the idea of capturing this debris. So we talked about deorbiting big pieces, but little pieces. I mean, there's a lot of little pieces. Nets, other things. Can you tell us what's the state of the art on ideas for capturing and perhaps reusing? I don't know if it's ganging the material together for 3D or additive manufacturing or what, but I would love to hear what's going on.
Well, there are a lot of ideas and there are a lot of prototypes, but nothing has been sort of 100% proven yet, as far as I know. But also that's because that's what they say, there's no real market. Again, the argument of nobody likes to clean up. As a child as well, cleaning up is not fun. So I think guidelines and rules are important to sort of set a standard, but I think it's also about what you were mentioning, like maybe we can reuse it or upcycle it. Then it gets a value, and then you get an incentive for change. So I think we have to sort of plug into this hyper-pragmatic attitude that a lot of space people have to fix it. So the solutions are there, but it's more how we activate them.
I think there's no technical solution for the 29,000 pieces yet. You see, collecting 29,000 pieces with a net will take ages.
Yep. You have a lot of shooting stars. Yeah, exactly.
So there's no perfect solution yet. But so the net is tested, it works. The robot arm, we have invested our own money in the early development phase, but going towards prototyping and testing will need additional money. So this we currently discuss with a couple of nations in Europe. But again, without incentivization, it will be difficult to explore that further. So we need definitely some kind of new rule and regulation framework that incentivize these kind of R&D work.
Or a couple of our satellites are being hit and Europe has no Facebook for 5 days, and then we fix it in 1 week. Yeah, most likely. Yeah,
yes.
It's also urgency.
Yeah. But just to emphasize, we had a space asset that's been up for 5 years, and we've gotten a warning once in that 5 years, and the warning was they were relatively far enough that you didn't need to action anything. So it's not so bad as the pictures would and the renderings would actually depict, but it's getting worse. Like you said, we will get to a point where operating a satellite is very difficult, and you'd need to use more fuel power if you do have propulsion on your satellites to be able to maneuver them so you don't collide.
Yeah, exactly.
I think it's a good point that space is still large.
Yeah.
This makes me wonder how far apart the average distance is between pieces of junk, but I don't.
They go 27,000 kilometers per hour, so it's hard to imagine in the end. And what you said, if they're smaller than 10 centimeters, we can't track them, but they're still lethal. So anyway, I think we should move beyond the what if and sort of create a new vision how we want a sustainable space. That's what we should focus on, in my opinion.
So I hope you've gotten a feel for the flavor of some of the things that our experts here can talk to you about. I know there's a microphone in the room. Is there anybody who would like to ask a question? I see a gentleman right in front of me here. And please say who you are when you ask your question.
My name is Shiva. I'm CEO of Curl Analytics. We are a data analytics.
You put the...
My name is Shiva, CEO of Curl Analytics. We are a data analytics company. I have two questions. One is, can you build satellites and rockets in such a way that there is less space debris? In the sense,
can we launch them
Can you design
with
it in
less
such a
debris?
way that they break less? They, once their life is expired, when their battery runs out, and so on. Second question is, you said the net works, but do you have to send one system of satellite or net to capture one debris, that is one large debris, or is it like one net can capture multiple? Then they should have a propulsion system and so on.
Yeah.
So I wanted to understand more about that. Yeah.
Someone like to take that?
I didn't catch all of it, so
The last
think
question was the multiple purpose of the net,
Yeah.
if I understood. Yeah.
no, I think that's what I said. We don't have a perfect solution yet to collect multiple debris, so to reuse and collect and then bring it down and deorbit it in a sustainable manner. This is some things we still have to look at. That's why the net is working for big pieces, and I'm sure it will do the job, but in order to collect 29,000 and beyond, we need other more sustainable solutions for mass collection, which are not available yet. And on deorbiting or burning, so you can.
I'll repeat it. Is there a way we can launch satellites or build them to reduce the amount of debris
Yeah.
they release in the first place?
That's a good one. Yeah.
I think this is what the design is, but the problem is, once a satellite gets hit by any kind of other material, you create little pieces of debris again. So hitting, and this is what the Kessler Effect is about, hitting pieces, you create always then dozens of other pieces, and if they hit again, they create hundreds of pieces and thousands of pieces. So the problem is that already now the space is pretty much congested by millions of pieces below 10 centimeters. And they become like missiles, 27,000 meters. So this could be used also on purpose, creating debris on purpose. If you want to destabilize a nation, you take out the Earth observation satellite, the telecommunication satellite, and the GPS system, and you go back into a world you don't want to see.
Yeah.
So you can create debris on purpose. It becomes quite.
But I like your question, because when you design a new satellite and you think about, okay, what if we would reuse it to 3D print or to create something, and you would include that in the design of how you make a satellite, it would look and behave in a completely different way. Right now there's a lot of toxic, battery, liquids, it's not that kind of stuff. I mean, it's beautiful, but so I think if you change the mental map of what it should be, you start redesigning it as well. And I think that's a big step
But the
that we
problem
should
is
take.
you need these solar arrays, and
True.
they already are very sensitive. So.
True. I'm not saying it's easy, but I think you should design it full circle, not just in a linear way, but in a circular way. That's I think, where it starts. Yeah.
There's a question over on this side of the room.
Sorry, first of all, thank you for the fantastic presentation. I think it opens up a lot of minds. My name is Nikhil Malhotra. I'm the Global Head of Innovation for Tech Mahindra. And this talk has been going around in a lot of circles in India as well. Yesterday, there was or maybe a couple of months back, a 7-year-old told me, why don't we do asteroid mining these days? Right, so these questions have started coming in from kids. My question to you guys is, how do you democratize all of this effort? How do you tell it to the world, where there's a race now for private firms to enter into the space economy as well? I think Google has started up a Lunar X Prize. It was started about 5 years ago, which essentially involved private firms building rockets, sending out satellites in the space with no or less government funding. But how does all of this talk that you do over here, or all this information, gets democratized in a world where you get a lot of these ideas? So that's my question.
No, I think you said it already, because access to space, the price per kilo has reduced so dramatically. It is already democratizing the access to space.
So that it becomes everybody's problem and everybody's solution. Yeah. Okay. Yeah. That's a good question.
Good question.
That's a really good question. Yeah.
I think, as you said, it's no one likes to clean up. So the problem is that's it will still take a lot of education and efforts of all nations involved in order to create the sense of urgency that is needed in order to start going into action mode. Today, it's a lot of discussions, not a lot of solutions. So I fully agree. We need to step up as governments, as institutions, and as private sector. But I don't see it in the next months. It will be quite some time necessary in order to get there.
So probably I'll go back to what you said with regards, when we start having an actual problem there, that's when the solution will come out. This is when
it's really hitting.
Yeah, when it's really, when you're really feeling it, I think that's when you start cleaning up. And it's unfortunate that that's the case, but it's understandable when you're talking about priorities and development priorities. And right now the priority is getting cheaper access to space. And that's a reality of the current state of the business, including the private sector that's currently up and coming. And we're at a transition point where the governments across the world are supporting the development of the smaller private sector companies that are then going to access the space. And it's still, the burden of development and the burden of risk-taking is still on usually government spending across the board in different countries. And that's why you see a lot of these companies that are actually profitable. A lot of them are profitable because of government contracts that are guaranteed to them for development. So we're at a state where the space economy is starting to evolve. We're not there yet for problems such as space junk and what do we do with it to be addressed from a private sector perspective.
Yeah, I think we all have a right for a clean space. Everybody has the right for a clean space, everybody, every country, every nation, every person. But we also have, everybody has a role in a clean space. So right and role, they have this beautiful, weird relationship. And I think having conversation like these helps us to sort of define that. What we do know is how it doesn't work. And so it starts with top-down guidelines or rules, setting a new standard, but it also requires a more creative attitude, make new connections between things that we haven't thought of before. So we are forced to be creative again, whether we like it or not. Yeah. So we don't really have a clear answer to your question, but it's a really good question. Yeah. Yeah.
Other questions that people might have?
I think if you would have the FIFA World Cup transmission be interrupted, I think that might.
Yep.
And suddenly people would realize that there is a sense of. No, it's like with the cybersecurity topic. If you 5 years ago when you went to company to talk about cybersecurity, they were like, nothing has happened. So they only start investing once they hit the wall. And this is the same as here. We need probably a demonstration how important space assets are to today's life before there's a wake-up call.
Would you ever go to space? Personally? Do you have plans? I'm just curious because this is your topic, no? If I'm allowed to ask, please.
No, we produced the European service model for Orion, which is part of the Orion mission of NASA to go into space.
Yeah.
And the second module is supposed to carry humans again. So probably one day it's not that far away. And if it would be possible not to lose 1 or 2 years, but go for a short mission.
Exactly. Yeah.
Otherwise, my family would not be so happy.
Yeah. Minister, would you like to go up? Yeah.
I wouldn't say no to going out to space.
No. Yeah, me too. Yeah, I think I'm always thinking about the astronauts. Like when they go up, they didn't look at the moon, but they looked at the Earth gazing. They looked for hours at this beautiful marble.
Yeah.
So I think, and everybody who came back, most of the astronauts who came back, became actually fighters for sustainability, promoters of sustainability. Said, okay, we have to redesign, renegotiate our way with planet Earth. So maybe part of creating the awareness of saving planet Earth is just bringing a lot of people up, looking at the world in a new way, and then bring them down again. And maybe that mental map will help to face our great challenges.
Just better understanding, just on that topic of how do you sustain Earth, just understanding how our neighbors, the planets around us, are such harsh environments for life.
For sure.
And looking at planets that could have at some point had life and have evolved and changed into planets that can't sustain life as we know it is very important to understanding the need to, one, sustaining Earth, and two, sustaining the space around Earth.
Yeah, absolutely. Yeah.
There's another question from the same gentleman.
I just wanted to comment on that. I think technology can solve a lot of that problem. We can probably have people go into space in virtual reality and probably showcase the sustainable effect of the planet as well as the other things. So you can probably do that sitting over here. You don't need to go to space to do that. That was just
Maybe.
One in the back of the room.
Thank you for the session. Mohammed Musa here. deep in AI in Silicon Valley. What do you think is the top opportunities for technology entrepreneurs in the space ecosystem? Where are the biggest pain points and big markets that people should focus on?
Did you hear that? Could you repeat that? It was
Sorry,
hard to, for some reason,
it's
it was
really
hard to hear
difficult
up
to
here.
understand.
What are the top opportunities?
Yeah. Where should entrepreneurs focus on opportunities in the space ecosystem? Both technology and platform access opportunities that have big pain points and high impact.
Okay.
So usually when people look at space, they think that a space developer is someone like Airbus Defence and Space here that develops an entire spacecraft from scratch, which is not the case. There's a lot of subsystems and components that go into satellites that are usually procured from companies that just develop that one component. And there's a lot of opportunities to optimize various modules that exist within satellites that don't have a large burden for companies to start in. And it's just developing the right component and having its space verified. And there's a lot of opportunity there because a lot of companies that exist are legacy companies that have existed for decades and have been using legacy technology that they're just developing incrementally. And we're at a certain point where we'd love to see components that are not from your typical line of components that have been developed and have been going into different spacecrafts for the last 15, 20 years. Heritage was important at a certain point, so heritage is how much a component has been used in space. Because the cost of access to space is lower, the cost of satellites is lower, now the appetite of taking less heritage for components is getting better. And the risk that is associated with it is reducing. And the typical design and development processes that go into it that require, for example, dual redundancy, 2 of everything across the board, and components that have been verified for hours upon years of use in space, is no longer becoming the case. And you're able to evolve that. And we have a case of doing it even on a mission that's going to another planet that has a higher risk. So on the Emirates Mars mission, we actually looked at every different component that goes into it and every design process and questioned why it was there. Why are we designing in this way? Is it something that we are doing just because it's a norm? Or is it something that we're doing because it's a need? And it's these discussions with various large developers that will enable new tech startups to feed into the process of development. So I think the realm is open not only for the developers of small satellites, but rather there's more value in development of components and subsystems that go into satellites that our typical developers work on.
In the past, you see, our people were trained with the slogan, first time right. Because once you launch, it has to work. You have no way of doing corrections. So our people were trained for perfection. And especially because you have a 4 years building time, you want to make sure that there's no mistake afterwards, because it's not, you can ensure the risk, but if you after 4 years have a launch problem or some kind of problem with the satellite going into orbit to the right position, you lose a customer, because the customer needs a product, and he has built a business model. And if he has to wait another 4 years to get another satellite, it's a serious problem. So our people were trained first time right, and you only can ensure first time right if you know your supply chain by heart, you know how they will react on the intense conditions in space, the vibrations during launch. So this is something that's not trivial. So that's why we, of course, were trained to have really experienced suppliers. But as you said, now looking at OneWeb satellite producing 2 a day, being able to launch very quickly again, it is a different ballgame. You can do mistakes, you can have a reduction of risk for your customer, but this of course changes also the supply chain. And you look at companies like Rocket Labs, quite impressive. They went from New Zealand to US to get started, but he built up a supply chain in New Zealand. They have never done anything in space before, but now they were trained what they have to do in order to be space system suppliers, And now they have a supply chain in New Zealand. Didn't exist before.
This is more an observation. What I noticed is when I zoom out and I look at the old missiles and satellites, when I go to Houston in NASA, they're very linear, very tall, very, like rock. And then it's interesting, like as space economy is sort of evolving, it becomes more biology. They look like spider webs. They look like jellyfishes. They look like origami. So I think it's, as a designer, it's very interesting to look at how space is evolving and how it's becoming more fluid. So in a way, it's becoming more natural or more organic in that way, the way it looks like and behaves. And I think that's a good thing if we want to create a sustainable space future. Yeah.
I think we might have time for one or two more. I see a gentleman in the back.
Good morning, Sam Ryan, McDonald. Just to Dan's point earlier, basically he said we have the right to clean space. In today's world, a lot of us have the right to clean cities, and there are environmental agencies which regulate waste disposal and so on and so forth. A lot of megacities are imposing CO2 and emission tax as well, which is unfortunately a bit too late in the day. I'm just wondering, with the jurisdiction around space being different, how practical is it for imposing a similar structure whereby there is a regulation around fee structure for cleaning space and so on, assuming cleaning space technology will become affordable with time?
Anyone want to take a...
Rules, guidelines.
Today, we don't have any rules in this regard, so of course it would be good to start early to discuss it. As you said, on one hand side, you don't want to stop to the innovation, because I think innovation will drive the knowledge that we also need here on Earth. But I think if we don't start early with some kind of rules and regulation, we will create, as you said also earlier, we create a big mess in space as well. So I think to find the right balance in regulation and, on the other hand side, driving innovation, this will be the critical issue. Do we have a perfect solution for that? Not at all. A lot of discussions ongoing, and I think the WEF is also driving a couple of discussions also between the big and smaller companies, institutions, governments, but I think we're still far away from a perfect solution.
Just to understand that let's not sustain, so the drive for this is we need more assets in space to better understand cleaner Earth and better understand the climate change that is happening here, and to continue to monitor it and to make the monitoring capabilities affordable to different countries so that they're able to better understand the changes in the climate that is affecting them as cities, as countries, and so on. So it's very important to stress the right balance when it comes to regulations and guidelines.
I think I would take the parallel with the plastic in the ocean. On one end, you need like Brussels, for example, abandoning a certain type of plastic or the plastic straws. That's top down. But you also need more like startups, like my fellow Dutchman, Bojan, with his ocean cleanup, harvesting and capturing the plastic in the ocean, which is more bottom up. I think you need both. If you only rely on regulation, we might be sitting here for the coming 10, 15, 20 years. It should happen, but it takes some time. So you need a sort of bottom-up tickling, and that's the projects I showed are hoping to do that, to put it on the agenda, to create the awareness, and make it part of a new standard, and they meet in the middle. That's when you create impact. So you need both. And I think, again, the fact that we're having this conversation and what you mentioned, to having this diversity of different countries and different stakeholders being engaged. This 2,000 students we did workshop with, the ideas they came up with were not that far off of the ideas the experts were already working on for 10 years. So there is a new generation which is very open towards engaging with space. And only then we will create a real solution.
And a solution can come outside the space sector, and that's very important to stress. Because solution to plastics in the ocean didn't come from plastic producers.
Nope. Exactly. That's a good comment.
A solution can come from outside space, and the more we talk about this, the more people hear about this, and the more dialogue they have across their various networks, regardless of the sectors they come from, perhaps we can find a solution that is economically viable, that
Yeah.
could be used as an analogy to what's currently happening.
So I think there we have it. I'm sorry, I think we could talk much longer, and that would be just lovely. A practical and a poetic agenda to put the topic of space debris and other ways we can all benefit from space back here on Earth. I think we've had a great conversation today. I hope you'll join me in thanking our great panelists and speakers. Thank you.
See you soon.
Pleasure, Louise. You did a great job. I really enjoyed it.
That was
Thank
fun.
you so much.
Thanks for your
Thank you.
calm and